Hello, everyone. Welcome to Inside iOS Dev, a show about real-world iOS development. Here with your host, Andrew Rohn.
And Alex Bush.
And today we have a very special guest. I'm really excited to have this person on. It's Florian Kugler. You probably know him from obc.io, website that's been around a long time, created great content. And the reason I brought him on is to talk about his newest book, App Architecture, which he co-authored with Matt Gallagher. And who is it again? Sorry, Chris Eidhoff.
Exactly. Thanks for the invitation.
We're glad to have you here. We're big fans of your website.
Thank you. Yeah, I think we started around 5 years ago, something like that. I'm not entirely sure, but sounds about right.
Yeah, and I think with your guys on the with obc.io, I think y'all really set a higher standard for the bar in terms of quality. I mean, when the issues would come out, I felt like they just had this, and I think it was kind of what y'all were going for, this like sense of like they were these magazines or like these well-crafted, curated topics, and I think a lot of people really enjoyed them. Me and Alex are both fans of them. Yeah.
Thank you. Yeah, so that was actually an idea by Chris back then. So we just wanted to start a blog, and then he said, hey, let's do a magazine. And it turned out to be a really good idea.
So it's App Architecture. I guess why this book? I mean, it's an MVC. That's what Apple tells us to do. Shouldn't we just all, stick to what Apple tells us they know best? So why this book? What is it going to help us do?
Well, I mean, obviously, not everybody is sticking to that. I think there's lots of activity in this area in the last, well, probably not just in the last years, but probably always, because people are always trying to find better ways to do things, and so MVC has a few of these very easy to point out shortcomings. Let's say, like for example, people's view controllers tend to get out of hand and stuff like that, and testing is maybe not possible in the way that people would like to test today, things like that. And so this architecture design space is being constantly explored. And so what we wanted to do is we wanted to just look at a bunch of different architectures and to not pitch a favorite or something, or not say, hey, here's the best one, because we don't believe that there is such a thing as a best one in the abstract. And so we just wanted to compare and contrast them and see what different choices, different design patterns make in the end. So that's the general approach of the book. It's not saying here are 5 patterns and this is the rank order from best to worst or something, but it's more like here are 5 patterns that handle things very differently, and we can learn from all of them.
What are the patterns? I'm sorry, by the way.
So, of course, we start off with Model-View-Controller, just standard Cocoa Model-View-Controller. And then we talk about Model-View-ViewModel with an added coordinator. And then we do a variant of MVC, which we call ViewState Driven Mvc. And then we cover one very experimental pattern, which is the Elm Architecture, which comes from the web. And we experimented with this on iOS. And we have another very experimental pattern that Matt came up with over the last years, which is called ModelAdapter-ViewBinder. And so we have these 2 widely used patterns, MVC and Mvvm, and then one in the middle, MVC variant, and then 2 very experimental patterns. And we chose those patterns basically because we thought they are sufficiently different to get different learning points out of each of them.
I'm curious, why did y'all decide not to include Viper, considering it's fairly popular in the iOS world?
Yeah, so this is a very common question. And so the reason is there are multiple reasons for that. So first of all, we felt that it's basically an extension of the same principle, from going from MVC to Mvvm. It's doing the same thing again, extracting more layers basically. So Mvvm says, okay, let's introduce the extra layer the view model layer.
Right.
And let's distinguish responsibilities in a clear way. So certain things are done by the view model, other things are done by the view controller, which is often just considered part of the view layer then. And so we insert this extra layer. And what's called often Viper, or I mean, there's a whole slew of architectures that you can group under this label of clean architectures, basically, if you follow this terminology, then this principle is just extended, basically. So you insert more layers. You'd have not just a view model and the usual components, but you have things like a presenter, which is very similar as the presenter in something like MVP, although you can always argue about this terminology. And then you have an interactor, and you have other components additionally to that. And so this is one reason why we didn't include it, because we didn't really feel that there's, in terms of learning from the pattern for any code base, basically, that there's much new in it. And then there's another reason why we didn't include it. And that's also, so we wrote the app, the example app that we present in the book and that we work with, we wrote it in Viper. And so we didn't just discard it up front. We really tried, and we wrote the app and we discussed it a lot. And our conclusion was that it's introducing all these abstractions too prematurely. So we thought that it creates, maybe especially for a simple project like that, but I think in general it just sets up a lot of rules up front and a lot of abstractions up front. And we felt that this is a bit premature, that it's good to introduce extra layers at the right points in your program to make things easier to maintain, easier to read, all these kind of things. But we felt that it's just too much upfront there. And we also scoured Stack Overflow and read a lot of questions about Viper and about related patterns. And we came away with kind of with the impression that there are so many rules that basically everybody's just asking about if he's doing correct, if they're doing it correctly. And basically you can always somehow, well, the thing is, it's on the one hand, there are many rules, and on the other hand, it's very under-specced, because it's Viper. We had an integral role also in bringing my Viper into the, into the public eye, let's say, because we published this article back then. But there's not extensive materials or extensive experiences with this pattern. It was just an idea, and I think it worked for some people, and it didn't for others. But there are a bunch of different reasons why we decided in the end to spend our time differently. It's not just, there are other patterns we could have included as well, and we just had to make the cutoff somewhere, and we felt that Viper wasn't really worth the extra time.
Would you say it felt too bulky, if you will, for 3 people?
Yeah, you mean in terms of for working on a project with 3 people, or?
I guess, yeah, it's kind of a small team, right? And there are so many rules that you don't really need that many rules and restrictions.
So keep in mind,
just 3 people.
So Florian, keep in mind, for context, Alex works at Uber currently with their riblet architecture, so it's rules is everywhere. So that might give you some perspective. But sorry,
go
ahead.
I definitely think that this is a factor, but I also think it's a. I get the feeling that architectural decisions often they are not just technical decisions. They are also decisions that have something to do with your temperament and your likings, and what you prefer, and maybe what works on your team, or what kind of people do you have on your team, what kind of understanding is there, and stuff like that. And so I always feel, So it's definitely related also to the way the 3 of us who wrote the book are working or have worked. So I guess that definitely plays a role. And there are a lot of different ways to solve this basic problem of writing a certain app. And I mean, if a pattern or if something you came up with works for you, then more power to you. But we had to write it from our perspective also, and from our perspective, we made this choice.
So yeah, that makes a lot of sense. And I'd like to go briefly one by one through those architectures that you listed, and to kind of, I guess, give us a gist for each, so that we understand, okay, the MVC and MVVM and coordinator is this, right?
Yeah.
MVC and ViewState is that, and so on.
Okay, let's try. So where do you want to start?
I think the first one is, we all know MVC, right? It's the good old Apple thing. So let's skip that.
Let's talk about MVC, because I'm sure that you'll add in some things there, some sort of prescriptive guidelines. So I think that'd be interesting.
Fair enough.
Yeah.
Yeah. So I think MVC, I learned a ton about MVC in this year. Maybe not things that were completely new to me, but things that were new to really express them in a articulated way. Before it was more implicit. And so what I mostly learned are the things that you have to that are easy to get wrong with MVC, and these are, I think, well, you could argue there's more wrong than that, but I think the two big things are that consistently applying the observer pattern, so that your view layer stays up to date with your model, is one big thing, because there's no enforcement there, and even no consistent pattern for that. And the other one is managing view state. So this is basically you just do it how UIKit does it, basically. So every component, every view or every view controller, every little component works like its own little machine and manages its own view state. And only if this approach doesn't work anymore, because you have to share it, then you come up with some ad hoc solution of sharing view state basically. And I think these two problems, or these two aspects for which there are no rules or no clear suggestions how to solve them, they can create huge problems if you're not aware of them, or if you don't plan for these issues to happen. So yeah, I think what I learned about MVC is mostly these points where you have to be very disciplined yourself, or come up with rules yourself.
Right, that makes sense. Kind of be aware of potential pitfalls, right?
Yes. Yeah, and it's just a trade-off of the pattern. So MVC is. We have recorded these videos also that go together with the book. So we have a bundle of ebook and videos. And one thing we did there, which was an idea from Matt, is we built 8 different architectures from scratch in a single app in 1 hour 20 or something, live coding. And so we have one view controller, and it has 8 different text fields and buttons, and they are all connected to the same model. And then for each of these text fields and buttons, we back them up by a different architecture. And in this example, it's very obvious, but the thing is, just to write something like this in MVC is trivial. It's super simple. It's very little code, very short. And then in all other architectures, it's more work to get this done. And so I think that's kind of indicative of what MVC is. It's just it's very loose. It gives you a lot of freedom, but then there's the other side of the coin to all this freedom you have to solve things how you see fit is a lack of guidance, and you have to come up with yourself. And there are a lot of areas where you have to make rules for yourself. So I think that's MVC.
And I think that last point is really poignant. And so I think what happens there, like you said, it gives you room to have to make up your own rules. And often people who are inexperienced don't know how to do that. And so they're like, the view controller, let's put it in there. And then thus MVC is born. I think that might be kind of one of the major causes of how massive view controllers started.
Yeah. So let's move on to MVVM maybe, or MVVMC.
Sure, yeah.
So there, I think the main point is to introduce this view model layer, which exposes a testable interface, which doesn't depend on the whole application feedback loop to be tested. And so that's the big thing there, actually. So that you have this view model component which takes the model and transforms the model into the data that is needed to drive your views. And there you have a clean interface against which you can test all the data that's going to be presented on screen, which is more challenging in MVC to do the same. And we do this in the book. We use RxSwift for our implementation, and we show also a little bit how you can handle the same if you don't want to use RxSwift to this extent or at all. But I think it's often connected somehow with the idea of reactive programming in the iOS community.
So you went for the classic, I guess both classic Mvvm with bindings and without them, right?
Yes. So I would say, well, what we settled on, it's always terminology. People are like interpreting these terms differently, but we settled on the idea that to call a pattern Mvvm, the binding layer basically is essential. So you want to have some sort of a binding mechanism between your view model and your views. And if you could say, well, you don't necessarily need bindings, you could propagate this differently through a delegate or something, right? And then we settled on that. We think this is more similar like something like Model View Presenter than Model View View Model. But it's just, there are no canonical definition of these terms, so it's a bit arbitrary at some point.
Right. Yeah, that makes sense. There are various flavors of Mvvm, if you will, and depending on how you implement it. And Andrea and I, we kind of also done both in our variation of that back in the day when we were working together. So yeah, that makes sense. So can you tell us what is this coordinator?
So the coordinator is just a separate object in the controller layer, you could say, which handles view controller presentation. Basically, it does everything related to managing your view controller hierarchy. And so just typical things like pushing view controllers, presenting them, popping them, all this kind of stuff. And so it's one responsibility more that you take out of the view controllers. So in a traditional, let's say, Apple sample code MVC app, each view controller is responsible for presenting whatever comes after it. And so this is taken out into this coordinator component. And the coordinator has basically knowledge of how all the different scenes are connected, and the individual view controllers don't, or the view models in this case, or whatever. You can easily apply the coordinator in MVC as well.
So it sort of plays a role of a router, if you will, right?
Yeah, you can also call it a router. It's kind of it's basically the responsibility of navigation. Yeah.
Got it.
Yeah.
Makes sense.
And so then maybe this comes back to MVC a bit. The third pattern, this intermediate pattern that we cover, this view state driven MVC, is this idea, or it takes this idea that in MVC, what's often a problem is managing view state. So you have tons of view state in your app. Each of your controls has internal view state, but then you have things like navigation state and scroll position and all kinds of other non-persisted state, basically. And some of it has to be shared across your app because some component in some part of your app depends on some state from somewhere else. And so this idea here is to really introduce a mechanism like that, introduce a mechanism like you use for model data for view state. So all of the view state is modeled just as your document data is, and it's pushed down into the model layer, basically. And whenever it changes, it sends a notification, as model changes often do. And then view controllers just listen to these notifications and make the necessary changes in the view hierarchy. So it really takes view state as something that belongs in the model layer, and instead of following this, you could say MVC/UIKit model that each view or each view controller operates as independently as possible. So it really changes this, and it's kind of there are things in UIKit that are a bit of a pain to work around, because UIKit is not really engineered to be used that way. But in general, it can be done. And then you can, once you have tried that, you can also just learn some good lessons from it, because you don't have to apply it in this extreme version if you don't want to, but you can apply it as well locally within a certain view controller to make handling all your view state easier, or you can apply it for the pieces of view state that you really need to share globally across your app.
So I'm a bit confused. It sounds really similar to me into Mvvm, where you said there's a binding updating mechanism for the view, and then this state that you have, although it seems the state for your view is truly in the model layer rather than having this other intermediary called a view model. So
Yes.
I'm a little confused on the difference.
Yeah, so the difference is really that Mvvm, as it's mostly interpreted on iOS, is still very, let's say, scene-based or something like this. So like you have a view model that is responsible for a certain screen, and then you have another one for your next screen or something like that. And what often happens in apps is that you get this requirement that you now somehow need to communicate between these different scenes that your app consists of. Or maybe you're on the iPad, you're presenting a master and a detail, or worse, you're on the Mac and you have different windows or all this kind of stuff that goes on at the same time, and you need to share state. And this is what this is about. So it's like even in Mvvm, you can run into this issue that you have to introduce some sort of a communication channel, communication mechanism that is across scenes. And this is basically an attempt, this is an attempt to show how this could be done based on MVC and not on Mvvm. But the principle could be very similar there.
Are the states stored in the one centralized storage, like
yes,
an object? So is it?
Yes.
Am I correct to assume that it's a little bit similar to Redux pattern architecture, whatever they call it?
Yeah, it definitely shares features.
Or it's similar at least, right? Yeah.
Yes, so it's also already, for example, one of the other patterns we still have is the Elm architecture. And so it shares similarities with that. It's very different in its implementation, but this idea behind it that all the state of your application should be represented by some sort of a value in your model, and it should be able to be restored from that as well, right? So it's very trivial to implement something like a time travel debugger in an architecture like that. And so this is the idea behind it, that the whole state of your app should be encoded somewhere in your model.
So let's talk about that. I know we're skipping the other one, but we can get back to it. But I'm curious. So Elm is like a more full-fledged, I guess, again, I just call it Redux type of model, right? Because I guess that's what I'm familiar with.
Global central store of state, basically. And then right.
And then observables, like view, roughly speaking, is an observable. Observes it and then reacts, right?
Well, the thing with the Elm architecture is that to make this work on iOS, you need an additional layer now. You need a framework. You need to build a wrapper around UIKit, because the difference there is that, yes, you have this one central store that represents the complete state of your app. But what you do then is you generate a virtual view hierarchy from the state. Anytime your state changes, you generate a completely new virtual view hierarchy. So let's say these are just enum values or structs or something like that. And then the framework takes these virtual views and does some, let's say, halfway smart work behind the scenes to apply these changes to the actual view hierarchy. So this is, in a way, it's very similar to what, for example, React Native does, or something like that, right? So there's this diffing step basically in there. So the idea, this is really much more, it's much more pure. So it's really functional in the sense that you have a function from state, which is the entire state of your app, to virtual view hierarchy. And you never write code like you never write code like bindings yourself, or code like if this, then change this property in this view or something. It doesn't exist. It's just a function from state to view. It's a pure function. And then you have this framework which has to do the heavy lifting, because of course UIKit doesn't work like that. And then you have to apply some diffing behind the scenes and be smart about updating your view hierarchy so that it reflects your new virtual view hierarchy. So this is it's pretty extreme, because it abstracts away all of UIKit basically from the developer. But it's interesting at the same time.
Yeah, it's with the React on the web, it's the virtual DOM thing, right? That yes. Construct of data that then gets mapped onto the bunch of HTML, right?
Exactly. Yeah.
But we don't have HTML. Instead, we have UIKit on iOS, so you have to sort of do the same, right? This virtual state UI state model, you have to map it onto the UI, and yeah, that makes sense. And I feels like it's a lot of work.
It is on the one hand, and on the other hand, it's not. It really depends what you need. So we have another video in the video series to the book where we built a basic version of this Elm framework in also approximately like an hour or 15, just live coding, and the real work comes in to support all of UIKit. That's the work. So because to get the basic mechanism going is not so difficult, but then you need all of UIKit's components. Maybe you need to support everything UIKit can do, and that means just a lot of wrapping. This is a lot of work to get this right. So there, on the one hand, it's like pretty straightforward, and on the other hand, it's implementation work to do to write all the wrappers.
Nice. Yeah, makes sense.
Let's go ahead and the final architecture you covered here. Let's go over that. It's this ModelAdapter-ViewBinder. Can you tell us about that?
Exactly. So this is basically what came out of a lot of experimentation by Matt. And so the idea there is basically to eliminate the controller layer altogether. So what's happening there is that it's basically the idea that you have, on the one hand, you have your model data, and on the other hand, you have these views, and you basically need to hook them up to have your model reflect the correct data and your views reflect the current model state. And what ModelAdapter-ViewBinder does is it wraps your model in a model adapter, which exposes reactive programming bindings basically, and it wraps your views in view binders, that therefore the name, and then you just establish bindings between them. And so you basically, this is also very declarative. So you just write your whole view hierarchy basically out up front in a declarative way, writing up all these bindings between your model properties and your views or view properties, and transforming the data in this process, of course. And then you have, again, a lot of help from the framework behind the scenes, which translates all that into, what UIKit understands, right? So also there, you don't really, it's in a way, it's much closer to UIKit than the Elm architecture, because it's a little wrapper around the views. And it's not this idea of regenerating the view hierarchy with each update, but you still have this framework behind the scenes that does this applying of these bindings to these views, because of course UIKit views don't expose any kind of bindings. So that's basically the idea there. Get rid of the controllers and just deal with this whole issue of connecting model and view with bindings and transformation pipelines along the way.
Right. Okay, so I feel like we've gone over the individual, and I kind of consider it like these vertical slices of these different architectures. Now I kind of want to think like horizontally to kind of wrap things up in terms of a lesson. Like, why do you think, what is common to all these architectures, and like, why are we here? Why are we talking about this? And like, what are they all similarly trying to solve? Like, what is the common theme that ties them together?
So I think the common theme that the common issue they all have to solve is this general this feedback loop that you have going on in every UI application, right? It's this loop from between your model data and the views on the other hand, and you do something in the UI, you click a button, you need to communicate this to your model, maybe your model changes, and then your view has to update. So this is this ongoing feedback loop that in a very abstract way represents all UI applications, basically. And so every architecture or every application design pattern tries to solve this. And then the differences really come in the trade-offs these different patterns make. And for example, as we talked about before, Model View Controller leaves you a lot of freedom to make your own choices. The Elm architecture, for example, on the other hand, says, I'm going to tie this down so that you, as the developer in the end, cannot do stupid things anymore. You cannot let your view state go out of sync across your app anymore or something, because I have tied things down so tightly that that you cannot make this mistake anymore. And so there's a lot of there's a lot on the spectrum. Of course, you can go to different points on the spectrum, but I think each pattern makes trade-offs like this. Each pattern has a different opinion on how much structure should be imposed upfront, or how much responsibility should be given to the developer in terms of having to be disciplined themselves, but getting more freedom in exchange, right? So but in the end, it's all just solving this old problem of driving a feedback loop in a UI application.
Great. Okay, I guess I want to wrap up here now. I think this is a huge topic, so this is definitely didn't do this justice. It's very difficult to do this in such a short amount of time. So I really recommend to anyone listening to this, you can go get the book now. It's App Architecture. Where would they be able to find it?
You can just go to objective-c.io, so objc.io, and you will definitely find it there right on the front page. And then we have a version which is the ebook plus this whole video series. It's a bit more than 7 hours, I think, of video we did together with the book. Or you can also just get the ebook if you like that. And we will also have a paperback version. If you like to read a paperback book, we will have that available on Amazon.
Oh, great. I love paperback.
Nice. Yep.
And I'll go ahead and add those links to the show notes as well. I highly recommend this to anyone listening. I personally was really excited for this book. I feel like it's long overdue for iOS. There's articles, blog posts, years going back of people decrying problems with MVC architecture and architecture in general. So I think this is great. So I highly recommend this to everyone. Thanks so much for coming on. Anything else you'd like to add, Florian?
Well, I think the only thing I would add is that I really, in the last year or a bit more of writing this, I really learned a ton by just experimenting a lot with this and writing a project in many different architectures.
Right. And
when do you do this normally, right? So I would really encourage people to just experiment with this stuff and to try out very different things. And because I can say that this was really enlightening for me to just have tried out so many architectures on a single project.
Yeah, I agree. There's one thing to read and take that information in, which is one sort of knowledge, but the experiential knowledge of doing things, I think, is often you can learn a lot more.
Definitely.
Okay. Thanks very much, guys, for listening. Alex, did you want to close up with anything?
No, just guys, go get the book. It's great.
Okay.
You'll learn a lot.
All right, everyone. Thanks for listening. You can find us on Twitter at InsideIOSDev, and you can find Florian Kugler, as we said, on OBCIO. They're also on Twitter as well. You can find them. So thanks so much, everyone, for listening. Take care.
Bye.
Bye-bye.
Bye.